All right, guys. So we're live. We're recording for the juniors. Well, it's not. The camera's not. I could. I was like turn around and. Yeah. All right. Anyway, so really, this section, before we talk about the shortcut for integrating, we still got to talk more about a little theory and some properties, stuff like that. So here are a few properties of integration that I want to go over with you guys right now. One property will look like this. Actually, well, that should be the other way around. Oops. No, actually, I got it right. Here we go. So if you were to reverse your lower and upper bound, so usually we expect from A to B, A is in the bottom and B is up top. But in this case, if B is in the bottom and A is up top, it's just a negative of that integral. That's all. So, exactly. Mm-hmm. So if you reverse the upper and lower bounds, just put a negative out in front. That's all. Just telling you that something you can do. Okay. What do you guys think about number 2? If the upper and lower bounds are the same, well, what would your area be? Exactly. 0. Because there would be nothing to find. Mm-hmm. If we're multiplying by a constant, like k times f of x, can that constant go outside? Yep. Same thing. So in this case, if your constant was negative f of x times dx, you can write it like this if you want. Or you can also write it like this if you want to get a little creative. So that's just utilizing the first property as well. I switch A and B. Yeah. If you have two functions being added or subtracted to each other, you're integrating that combination. This actually will be helpful for stuff we'll do later in this chapter. You can separate them exactly. So we can do that. Plus or minus. Okay. Okay, number 5. So here we have two separate integrals, right? But the upper bound of the first one. Exactly. So they will connect to each other. So B is kind of like a bridge. You can think of it that way. Yeah. No different. And actually, hold on, they're the same function too. I thought they were different functions. Yeah.
But it doesn't matter.
Actually, if that were the case, no, then we can't do it. They have to be the same function. Yeah.
It's the same.
Yeah. So note. Function must be the same. And of course, these have to be the same. And just give you a quick sketch. Let's say this is f of x. Yeah, if you integrate from A to B, you get all this. Integrate from B to C, you get all this. But you can just combine them from A to C. Upper, lower bounds. Yeah. Okay, this one, a little bit strange. Let me draw a diagram for you guys here. So let's say we have a function that looks like this. And let's say A comes down here. Say B comes down to there. So clearly that'd be my min. And up here would be my max.
Oh no.
What? So? So, now let's say I label this as point A. Let's say I label this as point B. Label this as point C. Label that as point D. Label that as point F.
Wait,
E.
even if they don't.
Yeah. So here's the deal. If I have two rectangles to look at, A, B, C, D, so the area of A, B, C, D will be less than or equal to, if I shade all this, be less than or equal to shaded area, which will be less than or equal to area of AB BF. I don't know, it's not a property really used much, but it's just important to know that if you have the maximum point and create a rectangle using that, actually I was a little off, I should have drawn my rectangle right there, but so my top left corner should have been right there, but I had it right there, it's okay. But if you drew a rectangle where you use the maximum value for the function and draw another rectangle using the minimum value of the function, the shaded area will always be in between those two. That's all it states. Those are just corners that I defined. So here's the minimum function, here's the maximum. But actually I should have drawn the rectangle.
Wait. Is F on F of X or is it on the
It's on F, it's on F of X. It actually should be right here. Actually, it should be right here, but I drew it in the wrong place.
Just sort of graph.
Yeah. But bottom line is, if you drew a rectangle using the maximum point as a vertex of that rectangle, so really what I should have done is ignore all this. That's really what I should have done. So the area of the big rectangle
Will it still work?
will still work. area of the big rectangle, and here's the area of the little rectangle, the shaded area will be between these two. That's all. Nothing really special. F should be the peak. Yeah, I kind of messed that one up. Oh well.
But you're including the shaded area as being under the minimum?
Mm-hmm. Yes, right. So that means, mm-hmm. So that means that B minus A times the minimum of F. Because see, that's the area of the bottom rectangle, right? Because B minus A is the base, right? And the minimum of F is your y value, that's your height. That'll be less than or equal to this. Think about the integral is the area of the shaded region. In the area of the big rectangle, B minus A is your base, right, for the big rectangle? And your height? Max F, right? That's why it's called the max-min inequality. But again, it's still something you don't really use or see very much. So I just want to mention that. Number 7. Here's another one. This one's called dominance. Fx is greater than or equal to g of x. So if that's true, that means that one function is always above another function. So this means that f of x is above g of x. So if I were to draw it maybe like this, here's f of x, and using a new color, say that were g of x. That also means that integrals will follow the same thing. Because clearly the area of the shaded region below f of x would be greater than the area of the shaded region below g of x. For no matter what you define as a and b. The area below the blue curve will be greater than the area below the red curve. Another thing to take note of, what if g of x equals 0? What kind of graph would that be?
A line.
Coinciding with x-axis, right? And assuming that f of x is always greater than or equal to 0, then your integral will always be greater than or equal to 0. Because basically you're integrating 0, which is 0. Let's keep moving. So now I'll do some examples. I'd like to see if we can finish this page, and I'll probably just stop there. Yeah, because next one's part 2. I'll say that for Monday. All right. So what we can do now is using these properties, we can evaluate each of these. And we get exact numbers. So what do you guys think about part A? Yeah, because you want to use g of x. Right. Because the negative of negative 2 will equal this. Which equals negative 2. That's right. Do you guys see that for part A? Why it's negative 2? We're taking g of x, but we flipped the upper and lower bounds. Okay. What do you guys think about B? It's a little tricky.
You combine the first.
And
Find the negative.
then flip it, right.
So it's -4.
Right, the answer would be negative 4. Again, here's the reason why. Negative 2 to 7 of f of x times dx will equal 4. But if you put a negative out in front, that gets what we're truly looking for, 7 to negative 2. Which equals negative 4. Okay, that's good. Well, let's see. Mm-hmm. It's 10. First we have a minus in between, right? So we can separate. Oops, that's 5. And then you have the constant multiples, right? And of course, then you can substitute. Okay. What do you guys think about D? Well, I can see why I say 20. But I'm going to put a question mark next to it.
What would you just do?
Why would I put a question mark? I see why I say 20, because you see the width, being of the interval doubling, right? Because the original width was from -2 to
Would it
3.
be 15? Is the height different?
Do we know?
No.
We don't know. It all depends on what the function's doing. No clue how f of x behaves beyond -2 to 3. We have no idea. Now, if it were a periodic function and one cycle, or the period was a 5, then sure, like sine. I mean, it repeats itself, like sine and cosine. But we have no clue what kind of function this is, so we really have no idea.
Do you not know if it's from
And why not?
Well, you don't know for g of x, the interval.
3 to 7, right? Not enough info, no clue how g of x behaves. From 3 to 7. We only know from -2 to 3. Okay, let's look at F. Let's see. So we know from -2 to 1 is -1.
Would it be 1? Or do you just not know?
Actually, hold on a sec. Let me look at this one again more carefully. -2 to 1. -1. No, but you're close. No, we know. We could do this. Think about it. From -2 to 1 of g of x. If you did this, right, you'd agree that this has to be true. And we know 2 of these. We know the first integral, and we know the third one, right?
What's the option?
Right. So essentially, it becomes this, right? -1 plus the integral of 1 to 3 has to equal 2. Because we already know what the right one is. That was given to us earlier in the problem. The first one on the left side, we're told that is -1, right? The integral from -2 to 1. So integral from -2 to 1 we know equals -1. The right side we know is 2. So if you add 1 to both sides, what do you get? Has to be 3. Because together they have to add the 2. But one is -1, so the other one has to be 3. Do you guys see that?
How do you know that's 2? Oh, that's 3 negative.
Yeah. Because 2 was mentioned earlier.
Why do you have 1 to?
because -1, you do need the opposite of that. Okay, last one. Then we can break to lunch. Alright, so let me do a rough sketch of this. Root x plus 4. 1, 2, 3, 4. 1, 2, 1, 2, 3. Change colors. So we start here. The y-intercept has to be at 2. And when we're at 3, it's root 7, which is like 2 point something. Now, I'm interested in this interval, right? It's a curve. Yeah, my apologies. But this is our shaded area, right? Where again, here we have 0, here we have 3. So that's what that represents. That's what we've defined what an integral is. What we want to prove is between 6 and 3 root 7. So in this case, we want to use the max-min property. So if we think about it, this is -4, 0. That's at 0, 2. And what would the corners for this be? The top right corner. 3 comma, or roots, what's the root 7? So here's how this works. B minus A times the min of F has to be less than or equal to your integral and that's supposed to be equal to B minus A times the max of F. Well, what's B minus A? It's 3, right? What's the lowest y value in our shaded region? Nope. Actually, sorry, for the curve, my bad, for the function. From 0 to 3. No, B minus A min F. Oh, you mean the right side? Yes, max F. Right.
Wait, so for the shaded or for the...
Sorry, it's not for shaded, it's for the curve. From 0 to 3, it's 2, right? And what is the highest y value? Root 7, right? So that's how you prove it. Again, it's not something you're really going to use very much, but just for this example, so that's all.
Is that our homework? Anybody?
Yeah, I'll sign the homework a little later this afternoon. So, all right, so we're all set. Root 7.